Alright, so in this lesson we're learning about limits from the left and the right, and this lesson is not hard, okay? One-sided limits are just like limits except you look at something from the left or the right. So for example, say we want to analyze the limit of x squared as x approaches 0 from the negative side. So you can kind of see how we put that little, oh wait, it's supposed to go on the right side. We put this little negative up here. It looks like my 0 has like steam coming out of its ears. Anyways, if we want to evaluate the limit of x squared as x approaches 0 from the negative side or the left side, then we would look at this function. And we would say that as we approach from the negative side, or the left, we're going towards this value. We're going towards the y value of 0. And that's it. So let's take the same one, but let's do the limit of x squared as x approaches 0 from the right, hence the plus. Well, we're going to draw the same graph. But this time we're going to approach 0 from the right. And again, it equals 0. Now there is some importance about whether the left and the right equal the same value, because that has to do with does the limit exist or not. Okay, so here the limit does exist because the limit from the left and the right are equal. Okay, so limits are especially useful whenever you're doing something with a radical. So I don't know why this foldable is really poorly set up, but they're useful for radicals. So let's go ahead and do a quick example. Like say you want to find the limit of the square root of 4 minus x squared as x approaches 2 from the, well, I don't know why that's useful, because it doesn't matter if we do from the left or the right. You can just plug and chug and you get 0. This book's definitely leading me astray, so that's really not that important. Okay, that's why it wasn't in the foldable. And now we go to this tab. Does the limit exist? We've already talked about this. We talked about if the limit is different from the left and the right, then the limit does not exist. This is just the mathematical definition of it. So it's saying the limit of f of x as x approaches c is L if and only if the limit from the right, or from the left, and the limit from the right are equal. So this one's from the left, this one's from the right. They have to be equal, and if they are, then the limit exists. And that's it. So it's just like a little proof thing that we're going to be doing, and we'll practice that in class. And then here we've got the definition of continuity on a closed interval. So in the last lesson we talked about continuity on an open interval or at a point, but here we're going to talk about at a closed interval. So again, you're going to have conditions. It's continuous on the closed interval if it is continuous on the open interval. So basically those 3 conditions we already learned. 3 conditions. And so if we just look back really briefly, we can see those 3 conditions where f of c is defined, the limit exists as you approach c, and then those 2 values are the same. If all 3 of those are true, then it's continuous on the open interval. But now we need to also look at the secondary condition, which says that the limit as you approach a from the right is equal to f of a, and the limit as you approach b from the left is equal to f of b. And an example of that, like in graphic form, would be right here. So say we have A and B. We go from this point down to this point. So you can see that there's no jumps or gaps or anything. So we can see very visually that this is continuous. But to talk about this second condition, what is the limit as you approach A from the right? Well, it appears to be whatever this value is, okay, which is f of A. So that tells us right there the limit is equal to f of A. And then the same for B. As we approach B from the left, what's it equal to? Well, the limit is the function is approaching f of B, which means that the limit is equal to f of B, and we've satisfied the conditions. So we'll try to look at some examples tomorrow from your homework that kind of actually use this knowledge, but for right now I just wanted you to get used to the notation for limits from the left and the right. Recall that it's undefined if the limit isn't equal from the left and the right, and then tomorrow we're going to be working with determining if a function is continuous on a closed interval. Alright, well, I'll see you guys tomorrow.